value. Okay, so 168 at the top. So you're going to write this down here. Nice and big expected value. That's one of the last things we need to learn. A value that can be calculated using, I will give you a different version of the formula than on your formula sheet. The formula sheet is different, but this one is better. This one actually walks you through the whole thing. So it looks like this. Expected value is equal to probability that you will win. This is on page 168. Okay. Probability that you will win times the prize minus the cost of playing the game on page 168. It's going to look a little scary, but trust me, you just plug in and you take your time. 2-3 steps down the road, you got an answer. Minus the probability that you will lose times the cost of playing the game, or buying a lottery ticket, or buying a scratch and win ticket, or if you go to any game and you want to be part of that game, you have to pay to play, right? So that would be the cost there. And so you box this one in because anything that's boxed in is worth entering into your study sheet. Maybe that's what we're going to do before we go today. At the end, we're going to put this on our study sheet so we know how to do that. So it can be calculated using that. Expected value is only accurate with a large sample size, meaning you're going to have to play the game for a bunch of times, like a significant amount of times before this is actually going to end up being an accurate representation. Okay? And there's 3 outcomes, and you need to be able to answer this question. The expected value will be a dollar amount. Okay? If you get a positive answer, right? You could get a positive, you could get 0, or you could get negative. This is on page 168. You could get a positive answer, you can get 0 as your answer on page 168, and you can get a negative. So what do you think? If it's positive, should you play or not? Yeah, then you're expecting a gain. 0, you would lose as much as you would win. So it's kind of like it's up to you. Negative is you're expecting a loss, consistently a loss. Don't play the game. That's how we answer this. So positive, gain expected, play. That's what I will say, right? You break even. We call that a fair game, right? It's not just like the person running the game will make all the money. Sometimes you'll win, sometimes, right? So it's a fair game. And here, loss expected. Don't play. So when you calculate it and I ask you, should so-and-so play the game, you base it on your answer. Even if you get this wrong, let's say you make the calculation, you get it wrong, but your answer is right, like the B part to it, you still get a mark there. Okay? I would say this is also it shouldn't take up this much space, right, on your study sheet, but I would tell myself positive, zero, negative, right? Good, nah, not good, right? Something like that. But I will scare you a bit more. You ready? There's there is a potential, like this is only when there's just one prize to be won, and then obviously if you don't win that one, you lose, right? But what if there's first, second, third, fourth, fifth, many prizes to be had? This formula just gets a little longer, okay? Multiple prizes to be won. Let's use this one. This is going to be a bit longer, so bear with me. Expected value is going to be probability of winning that first prize, so go sub 1. And I'm going to multiply that by the prize of the first one minus cost of playing plus probability of winning. This is probably the only one that I would add because this one covers all bases. Times whatever the price is for that second, it will be a dollar amount minus the cost of playing. And in math, when something is supposed to say, and this would continue for as many times as you have to, we would just go dot, 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 like that. Let me zoom in. I think I can do better than that. Hold on. Make sure you look carefully and you write it down like that. Minus probability. At the end of the day, there is going to be a loss, right? Expected loss. So then at the end, you go minus the probability that you will lose times the cost of playing. This formula is most definitely not on your formula sheet. This is just courtesy of Mr. Dirksen. Just like all the basically almost all the formulas. So if you were like, which one, Mr. Dirksen, should I do this one or the first one? I would just do this one. Because if there is just one prize, you just ignore that plus in the middle and it turns into that first one. Okay, so, and now I will ask you to go examples, right? Examples, go to page 8 in workbook. Okay, make sure you make a note of that. Otherwise, you're going to be like, where are the examples for this, right? Trust me, time flies, right? Next thing you know, you're in January and you don't know where you left your. And then so we take our workbook. I want to do at least one example before we go, at least one, okay? So we tell ourselves we're going to page 8 in the workbook. And in the workbook, when you go to page 8, I will do based on page 168 in notes, right? So you kind of cross-reference it. You cross-reference it on both of them. Okay. I will try to keep that formula up there. I don't know how well that's going to work, but there we go. can we just, before we start, the probability of winning, or the probability of winning many prizes and the losing, what should that add up to? We should always get 1 or 100%, correct? Because if it's 50% chance of winning, then this should be 50%. If they're 40, then this is 60, right? If this is 3 out of 5, then this will be 2 out of 5, right? Like if it's fractions. So make sure you always understand that that's what's happening. And you're like, what's gain, Mr. Dirksen? Yours doesn't have gain. Well, if you take the, can you wrap your head around this? If you win $10 on a scratch and win ticket and you paid $2 for it, how much did you gain? $8, right? That's what this is saying. And my formula takes care of that, right? Your prize is 10, your cost is 2, so you gained 8. Okay, so there we go. Let's start. Consider the following game. You have a 1 in 5 chance of winning. Obviously, there's a 4 in 5 chance of losing. I did not have to tell you that, but today we're going to take it easy, right? The game, it costs $1 to play. If you win, you receive $4. If you lose the game, you receive nothing, right? Obviously, you lost, right? Find the expected value. So if you see that, right? If you read and you kind of, I don't know where this is going, but if you see this, that's a dead giveaway, right? This is expected value. I'm supposed to use my formula for that. So let's go ahead and do that. Expected value, I'm going to write it out here, is probability of winning times the prize. How many prizes are there? Only one, right? So it's really just probability of winning. Take the prize minus the cost, and then go minus probability that you will lose times the cost of playing the game. You're basically making predictions here, okay? What's the probability of winning? 1 in 5. So we'll go 1 over 5 like this. The prize is 4, right? The cost is $1. Then we go minus. This comes here, right? Probability of losing. They were kind enough to tell me that, even though I could have figured it out myself. And what's the cost of playing? It's $1. Okay, so there's your cost. Did I tell you I like highlighters? Okay. And just clean it up. Clean it up. Okay, so I'm going to go 1 over 5. I'm going to leave that. This is 3, right? And this is minus 4 over 5. Nothing to clean up there. It is what it is. Okay. And let's go arrow like this, and we're gonna figure out the first part. So grab your calculator. Now today it might look pretty straightforward. It doesn't. Sometimes these numbers are bigger. Sometimes this is a decimal. So no big deal. 1 divided by 5, right? Equals. Multiply that by 3 and write that down. So see what my calculator tells me? That this here is 0.6. So you go expected value is equal to, this part here is 0.6 minus, then you figure out the next one. 4 divided by 5 is 0.8. Do I need to multiply it by 1? You don't need to, but I really like to press buttons, right? So there you go, 0.8. So you're almost done. Is it going to be negative or positive? It's going to be negative, but right, 0.6 minus 0.8. There we go, it's a negative. But watch this. At this point, I told you that it's going to be in dollars, right? And it's minus 0.20. So you're expected in the long run, you would be losing 20 cents every time you play in the long run, because sometimes you would win the $3 or gain $3, and you would keep playing, lose, and then win. But if you added that all up and you averaged it out, you're on average you'll be losing 20 cents a game. So loss expected. Why is that? Expected value is negative, right? Don't play. Even though it's not asking, we will keep saying that over and over and over. Do you want to do another one? I think we're good today, right? Your brains are fried. Yeah. This will be on the test. Yeah, but that's Wednesday, right? So on Monday, we're going to practice a bit more. I wouldn't AC you yet.